Hi students, now I am going to give shortcut method for hybridization. So without any formula we can calculate hybridization of a given inorganic molecule. Just to remember one thing that for example here number of sigma bonds plus lone pair equals to 2. Sometimes you are getting 3, 4, 5 and 6. Maximum up to 6 enough for inorganic molecules. If you are getting 2, sum of number of sigma bonds plus lone pair of electron, then what is hybridization? Sp hybridization. Next one, sp2 hybridization, sp3 hybridization, sp3d hybridization, sp3d2 hybridization. Okay, sp3d2 hybridization, right? For example, sometimes if you are getting 7, no problem, you can use sp3d3 hybridization. Okay, now this is the first important thing. Number of sigma bonds plus lone pair equals to 2, 3, 4, 5, 6, 7. What is the hybridization? 2 nothing but 2 hybrid orbitals, one s orbital and one p orbital. And 3, what is the meaning of 3? 3 hybrid orbitals, one s orbital and 2 p orbitals, like that sp3, sp3d, sp3d2, sp3d3. Just in order to give hybridization, we require the group number. If you know the group number, then you can give the hybridization. Okay, right? Now for neutral molecules, for cations and anions, 5 to 6 molecules I am giving. Now for example, if you are going to start with xenon difluoride molecule, XeF2 molecule. Now in case of XeF2, who is the central atom? Xenon is the central atom. What is the group number? 8th group. Now just I am taking 8 electrons, 3, 4, 5, 6, 7, 8 electrons. Now what is the nature of these fluorine atoms? Monovalent, bivalent or trivalent? These are monovalent species. Now two monovalent atoms are there. For each monovalent atom we are providing one electron. Now you remember this point also. For monovalent atom provide 1 electron. For divalent 2 electrons. For trivalent 3 electrons. Okay. After giving one electron, how many lone pair of electrons are there? 3 lone pair of electrons are there. Then you count number of sigma bonds plus how many lone pair? 3 lone pair. What is the answer? 5. 5 nothing but what is the hybridization? sp3d hybridization. sp3d hybridization. That's it. Next one, for example, xenon tetrafluoride is given. One more simple example, xenon tetrafluoride is given. How to find hybridization? 1, 2, 3, 4, 5, 6, 7, 8 electrons. Why? Because what is the group number of xenon? Group number of xenon is 8th group. 8 electrons. How many monovalent species are there? That means surrounded atoms. Number of monovalent atoms are 4. That's why I am taking here 1, 2, 3, 4. Remember this point. For each monovalent atom we are providing one electron. After that, how many lone pair of electrons are there? 2 lone pair. Then 4 plus 2. 4 sigma bonds plus 2 lone pair, 6. Then what is the hybridization? sp3d2 hybridization. sp3d2 hybridization. Okay, right? So one more neutral molecule I am taking, just like by using what bivalent atoms, XCOF2, XCOF2, combination of mono and bivalent. Again, who is the central atom? Xenon is the central atom. So 1, 2, 3, 4, 5, 6, 7, 8 electrons, right? How many monovalent atoms are there? 2 monovalent atoms, right? And one bivalent atom is present. For bivalent atom we are giving 2 electrons. Now here out of 2 bonds, one is sigma bond, one is pi bond. Sigma, again here sigma. We know that sigma bonds are formed by hybrid orbitals. That's why from 2 bonds in hybridization we consider only sigma bond. Totally how many sigma bonds? 3 sigma bonds. How many lone pair of electrons are there? 2 lone pair of electrons plus 2 equals to 5. Then what is the hybridization? sp3d is the hybridization. That's it. For example, one more molecule given like this, XeO3F2, same combination of monovalent and bivalent species. Then what is the hybridization? Who is the central atom? Xenon is our central atom. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay. Now here fluorine and fluorine. Next, how many oxygen atoms given? 3 oxygen atoms are there. What is the nature of oxygen atom? Bivalent atom, right? For each oxygen atom we are providing 2 to electrons. Now count the total number of sigma bonds. How many sigma bonds? Sigma, 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 sigma and sigma. Totally 5 sigma bonds are there. What are the number of lone pair of electrons around the central atom? 0. Then what is the hybridization? sp3 dehybridization. Okay. So this is the method for neutral species. For example, cations are what given like this. ClF4 plus is given. ClF4 plus. Now here who is the central atom? Chlorine is the central atom. Okay. Now what is the group number of halogen? Seventh group. But because of the presence of positive charge, we are taking one electron less than group number 1, 2, 3, 4, 5, 6 electrons only. Why? Because here cation is given. Around the chlorine, how many fluorine atoms are there? 4 fluorine atoms, monovalent, fluorine, fluorine, fluorine and fluorine. How many lone pair left? 1 lone pair. How many sigma bonds? 4 sigma bonds. Plus how many lone pair? 1 lone pair. Total 5. What is the hybridization? sp3 dehybridization. Formulas are not required. Directly we can calculate on the basis of this method, and this one is applicable for every molecule, inorganic molecules. Okay, few exceptions are there, solid BeCl2, solid PCl5, like that I will discuss at the end of this video lecture. Now one more cation I am taking. Yes, for example, I3 plus is given for same atoms. I3 plus is given. Here three atoms are given. Around the from three atoms, one is considered as central atom. One iodine is considered as central atom. And what is the group number of iodine? Just like I am writing like this. Okay, iodine, iodine and iodine. Let it is the central atom. And what is the charge on iodine? Positive charge. Positive charge. What is the iodine group number? Seventh group. But because of the giving positive charge, so what we are taking here, because of giving positive charge, now we are taking only 6 electrons. 1, 2, 3, 4, 5, 6 electrons. Okay, right. How many surrounded atoms? 2 surrounded atoms are there. Simply write like this, iodine and iodine. How many lone pair? 2 lone pair. How many sigma bonds? 2 sigma bonds. Lone pair 2. Total 4. What is the hybridization? sp3 hybridization. Okay. That is the simple way of calculating hybridization. Now neutral and cations are completed. Now let us take few anions. For example, here something like ClO4 minus is given. ClO4 minus. Now what is the central atom here? Central atom is chlorine, seventh group, but negative charge is given. So in place of 7 electrons, we are taking how many electrons? 8 electrons. What is the reason? Because of giving negative charge. Fine. Surrounded atoms are oxygen atoms. These are monovalent or bivalent? Bivalent species. For each oxygen atom I am giving 2 electrons. Okay, fine. Now here one is sigma, one is pi. Sigma, sigma and sigma. That you calculate. Now we have 4 sigma bonds. Then what is the hybridization? sp3 hybridization. Okay, fine. Come to next example. If SO4 2 minus is given. For example, this is our molecule SO4 2 minus is given. Who is the central atom? Sulfur. Sixth group. First you write 6 electrons. Yes, 6 electrons completed. And what is the charge given? 2 minus. Extra you write 2 electrons. And 4 oxygen atoms are there. Now all these are bivalent. Double bond O, right? Sigma, sigma, sigma and sigma. Totally how many sigma? 4 sigma bonds. Okay, fine. 4 sigma bonds. What is the hybridization? sp3 hybridization. Next I am giving very important molecules like N3 minus is given. How to find hybridization of N3 minus? 3 nitrogen atoms are there. So one nitrogen atom is considered as central atom, that I am taking here nitrogen. What is the group number? Group number 5. 1, 2, 3, 4, 5 electrons. But what is the charge given? Minus. That's why extra 1 electron. Okay, right. After that, what is the nature of your nitrogen? Trivalent atom. Because of giving trivalent atom, I am taking 3 electrons for each nitrogen. Okay, out of 3 bonds, just I am taking one is sigma bond, here also sigma bond. Then what is hybridization? 2 sigma bonds, nothing but hybridization is sp hybridization. Okay, right. Now come to another example. If O3 molecule is given, ozone is given, 3 oxygen atoms are there, one is the central atom, remaining 2 are what? Surrounded atoms. That's why I am taking here one central atom, oxygen. And what is the group number of oxygen? Sixth group. I am taking 6 electrons. And how many surrounded atoms are there? 2 surrounded atoms are there, bivalent. And how many lone pair left? One lone pair left. How many sigma bonds? 2 sigma plus how many lone pair? One lone pair, 3. What is the hybridization? sp2 hybridization. Okay, fine. This is the simple way of calculating hybridization. So whatever the type of molecule they are giving, like neutral, cation or anion, same procedure. For example, positive charge is present, we are taking one electron less than the group number. Negative charge is given, minus is given, one electron extra we are taking than the group number. 2 minus is given, 2 electrons more when compared to group number. Okay, right. And few important molecules are there. Now note these molecules, very important, like solid BeCl2 given, solid BeCl2 given. Now for these molecules we are giving hybridization on the basis of structure but not on the basis of previous method. What is the structure of BeCl2? It has polymeric structure, beryllium, and again here beryllium. Chlorine atoms arrangement is like this: chlorine, 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 again chlorine, chlorine acting as bridged atoms, right? After arrangement of chlorine around the beryllium, how many sigma bonds are there? Now we have 4 sigma bonds around beryllium. 1, 2, 3, again 4. These are the exception molecules. Now what is the hybridization? sp3. Normal BeCl2 is given, sp2 hybridization, but solid BeCl2 given. Now this one is the structure of solid BeCl2, and what is the hybridization of beryllium? sp3 hybridization. Come to another important exception, that is solid PCl5. Solid PCl5. Solid PCl5 existing in the form of dimer, that is available in the form of dimer, that is existing as PCl4 plus and PCl6 minus. Dimer nothing but twice, 2 phosphorus atoms, 10 chlorine atoms are there. Now by applying previous method you can calculate here hybridization. For example, PCl4 plus given. What is the group number of phosphorus? Fifth group. But what is the charge? Positive charge. Now we are taking only 4 electrons. 1, 2, 3, 4 electrons. How many chlorine? 4 chlorine atoms are there. Chlorine and chlorine. Then what is the hybridization? 4 sigma bonds are there. Hybridization sp3. Now come to PCl6 minus. 1, 2, 3, 4, 5, 6. Why we are taking 6 electrons? Phosphorus group number 5, but what is the charge given? Negative charge. Chlorine, 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 chlorine and chlorine. Total 6 sigma bonds. Then what is the hybridization? sp3d2 hybridization. Come to another important exception, that is solid or simple SiO2, silicon dioxide. Don't apply that previous method. In case of silicon dioxide, now this is the arrangement of silicon and oxygen atoms in the 3-dimensional structure. Okay, oxygen, silicon, oxygen, silicon, oxygen. Okay, again here oxygen, 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 oxygen and oxygen. Here also same thing. Now this is the 3-dimensional structure of SiO2. Around each silicon, how many sigma bonds are there? Number of sigma bonds, 4 sigma bonds. Then what is hybridization of each silicon? sp3. For example, if you want to give hybridization of silicon, every silicon hybridization is sp3 because of the presence of 4 sigma bonds. Next one, if you want to give hybridization of oxygen, around this oxygen atom, how many sigma bonds present? 2 sigma bonds. Plus how many lone pair? 2 lone pair. What is the number? 4. 4 nothing but what is the hybridization? sp3 hybridization. Now this is the very important. Now in case of previous molecules, now simply you can apply like this, okay, just by using group number. For monovalent atom we are providing 1 electron, bivalent 2 electrons, trivalent 3 electrons, you can calculate. But in these molecules, solid BeCl2, very important example. According to the structure we are giving hybridization. Next one, solid PCl5. Solid PCl5 available in the form of what? Dimeric structure. Now this is the dimer, cation and anion, PCl4 plus and PCl6 minus. In PCl4 plus, what is phosphorus hybridization? sp3. And PCl6 minus, what is phosphorus hybridization? sp3d2. Next one, SiO2. Where is that SiO2? This one. Three-dimensional structure. In three-dimensional structure, around silicon 4 sigma bonds are there. sp3 hybridization. Around oxygen atom, 2 sigma bonds plus 2 lone pair of electrons. Okay. Now 2 sigma, 2 lone pair, 4. Then what is the hybridization? sp3 hybridization. Now this is the shortcut method to find out the hybridization. Okay. Thank you.